Our goal over the next 3 class days is to solve quadratic equations, such as 5x squared plus 8x minus 1 equals 6. Now, when the highest power of x is a 2, then we call this a quadratic. So you see this 5x to the 2, emphasis on the 2, there's no x to the 3 anywhere. 5x to the 2 is the quadratic term, while 5 is the quadratic coefficient. So just the number in front of x squared is called the coefficient, is the quadratic coefficient. Similarly, 8x is the linear term, just introducing what this is called, while 8, just the number in front of x, is called the linear coefficient. -1 is the constant term on the left, and 6 is the constant term on the right. Again, the key thing here is to think about term versus coefficient. When we say the word term, we mean that terms are things that are separated by plus or minus signs, while coefficient just refers to the number in front of the variables, right? So I use that word very carefully, the number in front of the variables. That's why 8 is the linear coefficient. So when asked the linear coefficient, you don't want to say 8x, that's the linear term. The x tells you where to look, right? The x tells you to look in front of the x is the number 8. Interactive question. In the expression for x to the second minus 5x plus 6, what is the linear coefficient? Okay, recall that addition is gluing sticks and multiplication is the area of a rectangle. This becomes very important over the next 3 days, especially. So let's keep track of which operation corresponds to which geometric picture. Don't accidentally switch these. That is going to cause a lot of problems. So let's talk about this new technique called the zero product property. It reads like this. If a times b equals 0, then a equals 0 or b equals 0. So why is this true? Well, let's draw the types of situations where a times b equals 0. A times b, remember, times, that's multiplication is the area of a rectangle. So how could a rectangle have area 0? Well, this is what the rectangle could look like. It could be just a very, very, very thin rectangle. Like there's no height to it, like 0 height. It just has width like this. Or you could have a rectangle that looks like this. So this rectangle has height but no width, right? A width of 0. Or you could have both a height and a width of 0. You should just draw a single point. I just had to draw it a little bigger so you saw. So these are 3 very strange looking rectangles in that they're very thin, but because they're that thin, they're so infinitely thin, their areas are 0. And you see here, really in all 3 of these, a case where either the height is 0 or the width is 0 or both. And that is exactly what's being referred to here with a equals 0 or b equals 0, right? So yeah, again, you can either have the width bigger than 0 but the height 0, a rectangle that's so thin it's a line, or the height is 0 but the height is bigger than 0 but the width is 0, so the rectangle is so thin that it looks like a vertical line. Or you have both 0 and the rectangle is just a point. And here's the thing, if the whole point here is to say that if a rectangle's area is 0, it's because either the height is 0 or the width is 0 or both. And that, folks, just based on this geometric interpretation of multiplication, should give us all the reason we need to say, yeah, this zero product property really works. If 2 numbers multiplied together equal 0, in other words, they're the 2 sides of a rectangle, creating a rectangle with area 0, then one of the side lengths has to be 0. Okay, the geometric interpretation of multiplication is what convinces us that the zero product property here is true. So here's the point. If you ever see a times b equals 0, you can write a equals 0 or b equals 0 instead. This is going to be really nice. This is an awesome technique because it turns your complicated equation into 2 smaller equations, separated by the word or here. Now, when you apply the zero product property, we'll abbreviate the ZPP, you will turn one big equation into 2 smaller equations. That's nice. Instead of one big equation, have 2 smaller equations. You are required to write the word or between the 2 equations. To do this, it helps if you write both of the smaller equations side by side on the same line with the word or in between.